Hi guys. This is some 6-5 problems that I had planned to do in class with you. This document is posted in the agenda if you want to print it or if you just want to follow along on this. I do have hard copies of this if you wanted to get a hard copy on Monday. But I mostly just wanted to go through a few examples. I'll try to make this as quick as possible so it's not um, an incredibly long video. Some of these problems are long though. I'm not going to do 3 because it's kind of already stepped out for you a little bit, but I can tell you that in 3 you should get b equals -3 and a equals 2. So if you want to try that one on your own, you could. All right, so let's take a look at 11. So again, this method is partial fractions, and that's your last integration method that you need to learn. And you're going to recognize them because they're going to be fractions or rational functions like this, and they are probably going to be where the denominator can be factored. So if you factor the denominator on this, I'm going to keep the 7 on the top. And my denominator factors into 2x plus 1 times x minus 3. And I'm going to put the dx out there. All right, so then what you want to do is think about splitting it up into a over 2x plus 1 plus b over x minus 3. And then picture finding a common denominator here. If you found a common denominator, you would multiply this a by x minus 3 and this b by 2x plus 1. And so then that new numerator, we're going to say that would be equal to 7. So what I would have is 7 equals a times x minus 3 plus b times 2x plus 1. And then what we do is we want to think about, well, what would make this term 0? So to make this term 0, I would let x equal 3. So basically what I'm going to do is make this term 0 and then solve for b. So if this term were 0 and x was 3, I would be left with 7 equals b times 2 times 3 is 6 plus 1 is 7. So I would have that, or b equals 1. So that's one of my first solutions. And then you want to think, what would I let x equal here to make this term 0? So if I let x equal -1/2, that would make this term 0. So I'm going to solve for a this time. So I'm going to have 7 equals a. X is -1/2 minus 3. So this is 7 equals a times -7 over 2. Multiply both sides by the reciprocal, or -2 over 7. So -2 over 7, -2 over 7, and I get a equals -2 because 7 on the top and 7 on the bottom, 1 out. Okay, so then I could do a separate and integrate on this. I'm trying to decide whether I want to finish this example. Yeah, I'll finish this example, and maybe I won't do 17, but I'll let you do 17. So now what my integral is going to look like is a is -2, so I'm going to have -2 over 2x plus 1, plus b is 1, so 1 over x minus 3 dx. So now I'm doing these two integrals separate. Remember, when I'm adding, I can add them separate. In order to do this one, whoops, you can't see that, they're both going to be a u sub. So here I'm going to let u equal 2x plus 1. So du would be 2 dx, or 1/2 du would be dx. So this integral would become 1/2 the antiderivative of -2 over u du. And then here I would also do a u sub, u equals x minus 3, and then du equals dx. So this would be plus, would just become 1 over u du. Okay, so the antiderivative here, well, first of all, I could think about this, pulling this -2 out front, and -2 times 1/2 would be 1, so I'd have -1, and the antiderivative of 1 over u is natural log of u. And then this one would just be plus natural log of u plus c. And then substitute back in our u's. So here our u was 2x plus 1. And here our u was x minus 3. Okay, now on an FRQ, you're done. You've done the antiderivative. However, they will never leave the answer in this form for a multiple choice. So for a multiple choice, you can think this is like a -1 multiplied in front, and there's that power rule for logs that says if you have a number multiplied in front, you hop it up and make it an exponent. So if you have something to the -1, you can think about moving it to the bottom of a fraction. And if I'm adding here, I would be multiplying the log. So my first step might look like this. 2x plus 1 to the -1 times x minus 3. So this is all, combine them into a single log. Now this -1, I would send that to the bottom of my fraction. So it's the natural log of x minus 3 divided by 2x minus 1 plus c. Okay, so that rule I just did there looks like this. That's that power rule, they call it for logs. This one right here, if you want to try it on your own, the final answer is natural log x plus 1, x minus 1, absolute value of x squared plus c. And it looks like a good one to try. It's got 3 parts. You end up breaking this into an A, B, and C. So I would say that is a pretty good one to try. This is just the derivative they're telling you it's equal to here. So if you're solving for f, you want to go backwards here. So you're integrating both sides. These are some practice problems. I am going to look at the first part of this one. So if you had this problem, you might think, oh, looks like partial fractions, but I can factor the denominator, but I don't know what's happening with the numerator. So this kind of explains, sometimes you have to do some long division first. So I actually want to do the x squared minus 2x and divide it into 4x to the third minus 3x plus 5. So I'll be honest, this doesn't come up a lot on an AP test, but it does come up. So what I want to think here is, how many times does x squared go into x to the third, 4x to the third? Or what do I have to multiply if this times this needs to equal that? So if I have a 4x here, 4x times x squared would be 4x to the third. Then I want to do the 4x times the -2x also. So that would get me -8x squared. And then I want to subtract. So I do the negative outside the parentheses, so I remember to distribute. Now these should add to 0. 4x to the third minus 4x to the third is 0. That's what I want. Negative 3x minusing a negative plus 8x squared. This is going to get me positive 8x squared minus 3x. All right, so now I want to think x squared goes into 8x squared. We're going to say 8 times. Multiply the 8 by both of these, so I would get 8x squared. 8 times x squared is 8x squared. 8 times negative 2x is minus 16x, and subtract. 8x squared minus 8x squared is 0. Negative 3x plus 16x, so positive 16, negative 3 would be 13x, and then your next term that you bring down here is plus 5. Okay, x squared doesn't go into 13x, so this is my remainder. And if you remember when you do long division, this is how you write your remainder. So now this integral is going to become, or is equivalent to, this integral, 4x plus 8 plus 13x plus 5 over x squared minus 2x. Now, this you can just do your antiderivative like normal. So actually the antiderivative of that would be 2x squared plus 8x plus the antiderivative of this rational function here. This bottom factors into x times x minus 2. So I could split this up into a over x plus b over x minus 2. And then I would have a times x minus 2 plus bx equals 13x plus 5. So then you would continue on with your partial fractions there. I'll let you finish that, but I will tell you this is my final answer. Kind of funky numbers here. So that is the final answer. I can post this answer key also, but you can pause the video and write that answer down. These are some examples of partial fractions from previous tests. So I would recommend you try these. The answer for this one is A. The answer for this one is B. The answer for this one is B. The answer for this one is D. So practice those. Okay, now the other part of 6.5 are these logistical growth problems. Hopefully you watched that Khan Academy video that I recommended, and also, the regular 6.5 videos. But this is just kind of a review. I can't remember where I got this from, but this is the formula for, this is the rate of change. Oops. And then I think one of the videos in your notes showed solving this, so doing the integral of both sides to get the function for the population. Okay, so and this A is your initial amount, e to the negative kt, k is a constant. Hopefully that is a little bit of review from the videos that you've already watched. This is what these graphs look like. And remember, this here, this y value here, is what we call the carrying capacity. And then remember, halfway between here and here, between 0 and the carrying capacity, is always where your max growth happens. These are typically the two things they ask you about in these questions. So carrying capacity is M in this formula up here, capital M. So max growth is going to be M divided by 2. And that's where this function is growing the fastest. So we have a question here. So it says, suppose that the population, okay, here's our logistical growth differential equation where T is measured. So then they ask us some different things. So this one is not in the exact form that we want it to be. We would like it to be in this form so we can find that carrying capacity pretty easy. So if you look at this, what we want is to have this P by itself, I'll say, like a plain old P. Let me start first by, yeah, so what I want is I want carrying capacity minus plain old P. So think about, I want to factor out a 0.002 P. And then remember, so I'm going to write factor out. Factoring is just the same as dividing both of these terms by that. So if I divide both of those terms by that, I'm going to get 0.002 P 100 minus P. So the goal is to get a plain old P here. So if I divide this by 0.002 P, I'm left with a plain old P. This is my M, so that's my carrying capacity. So now I can probably answer these questions. If P of 0 equals 5, what is the limit as time goes to infinity? So as time goes to infinity for these graphs, your graph is always going to approach your carrying capacity. Your carrying capacity is actually like a horizontal asymptote. So the limit of this is going to be 100. It's going to be my carrying capacity. My population can't grow beyond this carrying capacity. And then it says if the initial value is 60, what is this limit? It doesn't matter what you start with. Your limit is going to be your carrying capacity, your horizontal asymptote there. If the initial population is 120, what's going to happen as time approaches infinity? You're still going to approach 100. So then it says to sketch this. That isn't not so important. The one thing I would add to this is if they asked you when is the function growing the fastest, then that would be at m over 2 or at 50. So it would be your carrying capacity divided by 2. All right, I will scan these for you also if you want to see I don't have the work for the multiple choice, but I have the work for the ones in the front. All right, that's it. Hope this video was not too long.